Hi, this is Mike, aka Mythrander with Team Flying Circus with your helpful building trick. I'm here with Rabbit Ron.
Let's talk about me.
And we're going to show you how to lay out the cables in a 40%er with a pull-pull system. So, if you look inside this nice airplane here, you'll see that Rabbit Ron has already located the servo tray in place with the bell crank. And what we need to do is at the back of the airplane, in this area somehow, determine where these cables exit the fuselage without cutting a slot that's 8 inches long. So hopefully if we get this right, we'll have to cut a hole maybe a ½ inch to an inch long. To start this process, you put the bell crank in the neutral position, and if you want, take a small piece of tape and just tape that guy so he doesn't move, because you're going to be referencing that guy. Okay? Take small pieces of tape and mark the rail of the airplane approximately flush on a fuselage station where those cables terminate on that bell crank. And that's about here and here. Then you want to take a piece of tape and run straight down from that point. With this airplane, the canopy rail is approximately parallel to the aircraft center line, so we want to try and make the tape perpendicular to that canopy rail. Another piece over on the other side, not like that. Okay. So now that we've marked the side locations on the fuselage, we take something rather straight and our scale, and we measure from the horn up to this rail height, this canopy rail height. And that is about 6 7/8 of an inch. We take that information and we measure down 6 7/8 of an inch. And that height is important because we're going to project that height back to the horns on the rudder. Okay, we'll do 6 7/8 on this side. Okay, there's our height. Okay, our next step is to take our scale, if we don't already know, and measure the width of our horn, of our bell crank on the inside. This is a 5-inch bell crank. Okay, good. It measures 5 inches. We're going to need that 5-inch number. Once you do that, you take the airplane and rotate it upside down. On a nicely padded surface. And we need to add another piece of tape across these two pieces of tape here. Okay. Don't want to lose my marks. Ron did a good job getting that bell crank centered over the seam line of the fuselage, so I can use that as a reference line. Okay. It's 5 inches, so I measure 2.5 and 2.5. Okay. That's the width of our bell crank. This line over here gives us the depth of our bell crank. Then we take our chalk line. The first step is we take a little piece of tape and we take this guy just like that. Okay. Just like that. Okay, so now that we've marked our chalk lines and taped them to the marks we did on the bottom of the airplane, we're going to cross these cables in this airplane, and I'm going to pull them straight back to where they hit the rudder. Okay, you want to take your rudder in neutral and put these guys right straight back. And then if I line up my eyes with the side of the fuselage, I can see where this chalk line exits the fuselage, and it's about there. So I can take my pen and I put a little vertical mark right there on the tape. Okay? I come over and do the same thing on the other side. That gives us the lengthwise location of where these cables will exit the fuselage, or the fuselage station where they exit. And you want to make sure that left and right are about at the same location. The next step is to get the height of this cable where it will exit the fuselage. So we take our line and we tape it right here on this line here that we did before. And then I pull it right to the center of this horn. Okay? Center the horn up against the fuselage. And right there is where that cable is going to want to exit the fuselage. So, join these two lines. That's the hole where it's going to exit. Okay, let's do the same thing on the other side. So that is the theoretical location where the cables will exit the fuselage. We're going to start cutting and see how close we are. So now's the time to find out if we did this right or not. In the next few minutes, we're going to find out if Ron's happy or if Ron is angry at me. So we're going to go ahead and cut this first hole. Always use safe personal protection equipment. The tool that we're using is a structured tooth tungsten carbide bit. You can get these from Dremel. They're specifically designed for cutting composite. If you cut metal with them though, it dulls them and loads them up real bad. Okay, so we went ahead and took some of that chalk line that we were using and we ran it through the holes that we cut on both sides. We pinned it with a couple of screws and we've got it on the bell crank up front. And it works very nicely. We're not observing any tension increase or decrease. And one of the things that you'll notice is when the rudder is in the neutral position, the distance from the hinge line to this guy is the furthest out. Both ways, this screw gets closer to the fuselage. This hole that we cut is the theoretical furthest forward extent of where that hole should be. So now what we need to do is slot this guy back about 1/2 inch to 3/4 of an inch and it'll work perfect. Okay. You'll notice as I hold the Dremel, I align the axis of the Dremel with the hole and the center of that guy, and I have it at acceleration. That gives me an exit, which is kind of chamfered to be parallel with the cable itself. These are the little exit covers that we got. They're feel like some folded up aluminum, and we'll need to do a little bit more dressing up on this slot to probably increase it a little bit. But even if we add another 1/2 inch to the length, the cover more than goes over the entire slot that we needed to create. And that is how you do the pull-pull rudder cables. So, thanks for joining us on this. We hope that it will be helpful on your next big project that you do. This is Mike, a.k. Mithrander, and Rabbit Ron